Okay, this is the first of the last three videos. The first two I'm expecting you to look at, the third is optional. So in this one, I'm going to explain why that's true if f of x is a power series of this form. And remember, what we're doing is we're thinking that we have a function f of x that's difficult to understand, cosine sine e to the x. We want to write it as a polynomial, an infinite polynomial, in this form, because that way we can compute with it. And I want to show you why that if we do this, that's what we get. And my method, it's fairly, I don't think it's too bad. I assume that this is true, and I take derivatives of both sides, and then I plug in x equals 0 and solve. So it's kind of a different way to solve an equation. I think it's an interesting solving technique. So for the 0th derivative, that's my f of x. I don't need this anymore. Sorry to jar you like that. That's f of x, and remember that my 0th derivative is the same as the function. And I plug in 0, I get a1, I get a0, sorry. I get a1 times 0, a2 times 0, a3 times 0. So everything with a 0 goes out, so I'm just left with a0. Now I'm going to want this information, so I'm going to record it on another piece of paper and come back to it. So what I get here is I get a0 is equal to f0 at 0. Okay. So now I'm going to take the first derivative and plug in x equals 0. So the first derivative, that's going to be 0. That's going to be a1. That's going to be 2 times a2 times x. That's going to be 3 times a3 x squared. 4 times a4 x cubed. I'll do one more. 5 times a5 x to the 4th. Okay, I plug in 0. Now notice all these terms are going to go to 0, so I'm just going to be left with a1. And again, I'll indicate it here briefly. That's going to be 0. 3a3 times 0. Those are all going to be 0, so I get a1. So I'm going to record that back here. I'm going to get a1 equal the first derivative at 0. Okay, now I'm going to continue with this. So I'm going to slide that up, and I'm going to keep our method at least for a little bit longer. And I'm going to start doing some more computations on here. And I'll slide this up as we go. So now I take the second derivative. So that's going to be the derivative of this, 0. I'm going to get 2 times 1 times a2. I'm going to get 3 times 2 a3 x, and so forth. 4 times 3 a4 x squared. And finally, this last one, 5 times 4 a to the a5th, a cubed. Okay. Now I'll do the same thing again. I plug in 0. I'm going to get a 2 factorial a2 here, and all these other terms are going to be 0. So that's what I get. I'm going to record that. I'm going to get 2a2 factorial equals f second derivative, therefore a2, I'm sorry, it's 2 factorial times a2. Therefore a2 equals the second derivative at 0 over 2 factorial. Now you're starting to see a pattern, I hope. So we'll do this maybe 1 or 2 more times. So the third derivative, this is time consuming, but it works. That goes to 0. This is going to be 3 times 2 times 1, a3. 4 times 3 times 2, a4. Notice that matches x. 5 times 4, bring that down, 3. a5, x squared now, and so forth. Well, you can see what's going to happen. I plug in 0. I get 3 factorial a3. All these terms are going to be 0. That's going to go to 0. So I'm going to get a 0. So again, I'll record that over here. We get 3 factorial a3 equal the third derivative over 0. Therefore, a3 is the third derivative, 0. 3 factorial. I'll do one more and that'll be it. Okay. So I'm going to slide that up a little bit. We'll do the fourth derivative, same method. And then this will be the last one. I take this one, that goes to 0, it's a constant, so I get 4 times 3 times 2, x to the 1 times 1, a to the 4th. We all know what that is. Bring down the 2, 5 times 4 times 3 times 2, a5, x, plus dot dot dot, plug in 0. That's going to be 4 factorial, a4, and everything else, that's going to be 0, so that's going to be 0. Okay. So again, I'm going to switch to the second sheet. So let me get that centered. So we get 4 factorial a to the 4 equals the fourth derivative at 0. So a4 is this. So again, here is our terms. Now, we have a clear pattern here. But how about here? Well, this is over 1, and 1 is 0 factorial. That's one of the big reasons 0 factorial is 1. A1, well, this is over 1, and 1 is 1 factorial. So now it works. So here's our pattern. AK equals the kth derivative at 0 over k factorial. Again, you don't need to know this, but maybe an extra credit problem here. Possibly, but again, it's not required that you understand this. Okay, I hope this makes sense. Just a quick review. Our goal was to show why this was true if we're assuming this. We had a method. I did that method over and over again. I wrote down my results, and we looked at the pattern. The pattern's fairly clear, and that's it. So, enjoy.